ordinary derivatives. Let's consider a mathematical function of one variable fx. What does the derivative df by dx do for us? It tells us how rapidly the function fx varies when we change the argument x by a tiny amount dx. That is, df proportional to dx and df is equal to df by dx times dx. In other words, if we increment x by an infinitesimal amount dx, then f changes by an amount df, and the proportionality factor is the derivative. For example, the function shown in this figure varies slowly with x, and correspondingly the derivative df divided by dx is very small. In the second figure, f increases rapidly with x so that the derivative is large as you move away from x equal to 0. So the geometrical interpretation of the derivative is that it is the slope of the graph of f versus x. The gradient. To understand gradient, consider a room as shown in this figure. We are going to measure the temperature in this room. We set up a system of axes at one of the corners. The temperature T is a scalar field and is a function of x, y, and z. From the theorem on partial derivatives, the scalar field T can be written as dt equal to dou t divided by dou x times dx plus dou t divided by dou y times dy plus dou t divided by dou z times dz. This equation tells us how t changes when we alter all the three variables by infinitesimal amounts dx, dy, and dz. And this equation can be represented in terms of a dot product as dou t by dou x, x cap, plus dou t by dou y, y cap, plus dou t by dou z, z cap, dot dx x cap, dy y cap, plus dz z cap, or del t dot dl, where del t equal to dou t by dou x, x cap, plus dou t by dou y, y cap, plus dou t by dou z, z cap is known as a gradient of the scalar function t. Let's now try to understand the geometrical interpretation of gradient. Like any vector, the gradient has magnitude and direction. To determine its geometrical meaning, let's rewrite the dot product as dt equal to del t dot dl, which is equal to modulus del t times modulus dl cos theta. And dt has its maximum value when theta equal to 0 degree. In that case, cos theta is equal to 1 and dt equal to magnitude del t times magnitude dl. This equation is reminiscent of the ordinary differential equation that we have seen just now. That is df equal to df by dx times dx. That means that a change in the temperature is directly proportional to dl, where dl is the direction along which the variation of t is measured, and the proportionality constant is magnitude of del t, which is the gradient. From this equation, we understand that the gradient del t points in the direction of maximum increase of the function t. Also, modulus of del t gives the slope or the rate of increase along this maximal direction. To bring home this point, let us consider another example. Let us imagine that we are standing on a hillside. Let us take the scalar function as the height of the hill, which is a function of the latitude and longitude. Now let us look towards its steepest ascent. this is the direction of the gradient. Now measure the slope in this direction, which is rise over run. That is the magnitude of the gradient. Note that the direction of maximum descent is opposite to the direction of maximum ascent. What would it mean for the gradient to vanish? Del t equal to 0 at x, y, z, then dt is equal to 0 for small displacements about the point x, y, and z. That is, we have a stationary point for the function t, x, y, z. It could be a maximum, that is at the summit, or it could be a minimum at the valley, or a saddle point or a shoulder point. So in short, a gradient tells you about two important things. The magnitude of the gradient indicates how quickly the field is changing over space, and the direction of the gradient indicates the direction where the field is changing most quickly with distance. Therefore, although the gradient operates on a scalar field, the result of the gradient operation is a vector with both magnitude and direction. Let's now try to solve this problem. Find the gradient of the function f(x,y,z) equal to e power x sin y ln z. We have the gradient del f equal to x hat dou by dou x plus y hat dou by dou y plus z hat dou by dou z ex sin y ln z. This is equal to e power x sin y ln z x cap plus e power x cos y ln z y cap plus e power x sin y 1 by z z cap. So this is the gradient of the function f(x,y,z). Now we shall try to crack problem number 2. It is given that the height of a certain hill in feet hxy equal to some mathematical function, where y is the distance towards north and x is the distance towards east of South Hadley. North, south, east and west. So this is the South Hadley. There are three parts for the question. Part A, where is the top of the hill located? Part B, how high is the hill? And part C, how steep is the slope in feet per mile at a point 1 mile north and 1 mile east of South Hadley? In what direction is the slope steepest at that point? Now we shall try to solve one by one. Part 1. Where is the top of the hill located? To find out the answer for this one, we'll try to solve the gradient of h. This is equal to del of 10 2xy minus 3x square minus 4y square minus 18x plus 28y plus 12. The gradient is nothing but x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z, and then the mathematical function for h. So when we expand, we have 10 times 2yx cap plus xy cap minus 6x x cap minus 8y y cap minus 18 x cap plus 28y cap. So when we rearrange the terms for x cap and y cap, we'll have 10 2y minus 6x minus 18 x cap plus 2x minus 8y plus 28 y cap. Now we are asked to find out the top of the hill. So if this is the location, North Headley, we want to find out where exactly is the location of the top of the hill. It can be here, it can be here, it can be here or here. To do this problem, we recollect that gradient of a function always points towards a maximum increase of the function. And we also know that at the summit, the gradient is equal to 0. Therefore, we can very well equate del h equal to 0. Therefore, at the summit, del h equal to 0. This means that 2y minus 6x minus 18 x hat plus 2x minus 8y plus 28 y hat equal to 0. Or precisely, this is 0 times x hat plus 0 times y hat. When we equate the terms of x hat, we have 2y minus 6x minus 18 equal to 0. And then when we equate the terms of y hat, we have 2x minus 8y plus 28 equal to 0. Now we want to solve for x and y. Let's rewrite this equation as equal to minus 6x plus 2y minus 18 equal to 0, and then multiply this equation with 6 so that the equation now becomes 6x minus 24y plus 84 equal to 0. When we add these two equations, we'll get minus 22y plus 66 equal to 0. So this gives y equal to 66 by 22 equal to 3. Now we'll take this equation and substitute for y to get x. That is minus 6x plus 2 times 3 minus 18 equal to 0. That is minus 6x minus 6 minus 18 equal to 0. This gives minus 6x minus 12 equal to 0, or x equal to negative 12 divided by 6, that is equal to minus 2. So these are the coordinates for the top of the hill. And it will be somewhere here. That is 3 miles up and 2 miles towards the western direction. Now part B, how high is the hill? We have found out the location of the top of the hill, which is x equal to minus 2 miles and y equal to 3 miles. We have 10 times minus 12 minus 12 minus 36 plus 36 plus 84 plus 12. This will be equal to 720 feet. Finally, to the third part. How steep is the slope in feet per mile at a point 1 mile north and 1 mile east of South Headley? In what direction is the slope steepest and at what point? That is, there is a location which is at 1 mile north and 1 mile east. We have to find out the slope of the hill. To find out the slope, what we do is that we will take the magnitude of the gradient. Given that x equal to 1 and y equal to 1. Therefore, gradient of h equal to x hat dou by dou x plus y hat dou by dou y plus z hat dou by dou z, and this function is 10 2xy minus 3x square minus 4y square minus 18x plus 28y plus 12. This is equal to 10 times 2yx hat plus xy hat minus 6x x hat minus 8y y hat minus 18 x hat plus 28 y hat. Now let us substitute for x and y, which is equal to 1. Then this is equal to 2x hat plus 2y hat minus 6x x hat minus 8y y hat minus 18 x hat plus 28 y hat. This is equal to 10 times minus 22 x hat plus 22 y hat. This is equal to 220 minus x hat plus y hat. And the magnitude of the gradient is equal to 220 square root of 1 square plus 1 square. This is equal to 220 times square root of 2 feet per mile. This is the first part. How steep is the slope at a point 1 mile north and 1 mile east of South Headley? And the second part is that in what direction is the slope steepest at that point? So the direction is northwest. Problem number 3. Let vector script r be the separation vector from a fixed point x prime, y prime, z prime to the point x, y, z, and let script r be its length. The question has 3 parts. In the first part, we have to show that gradient of r square is equal to 2 times vector script r. We know that script r is equal to x minus x prime x hat plus y minus y prime y hat plus z minus z prime z hat. And the magnitude of r is equal to square root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. And r square will be equal to x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. We have to find out the gradient of r square. This is equal to x hat dou by dou x plus y hat dou by dou y plus z hat dou by dou z, and x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. Okay. When we do the operations, we'll get 2x minus x prime x cap plus 2y minus y prime y hat plus 2z minus z prime z hat. This is nothing but 2 times x minus x prime x hat plus y minus y prime y hat plus z minus z prime z hat. This is equal to 2 times vector script r. In part B of the problem, we have to find out the gradient of 1 by r. So the gradient of 1 by script r is equal to gradient of 1 by square root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. This is gradient x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square, the whole power minus 1 by 2. When we do the mathematical operations, we'll get minus 1 by 2 times x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square, the whole power minus 3 by 2 times 2 x minus x prime x hat plus 2 y minus y prime y hat plus 2 z minus z prime z hat. This is equal to x minus x prime x hat plus y minus y prime y hat plus z minus z prime z hat divided by square root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square to the power 3. At the numerator, what we have is vector script r, and in the denominator what we have is script r cube. And vector script r can be written in terms of the magnitude and unit vector along the direction of r as r hat divided by r cube. This is equal to r hat divided by r square. Let's now do the C part. What is the general formula for gradient r script to the power of n? So we know that gradient is x hat dou by dou x plus y hat dou by dou y plus z hat dou by dou z. To simplify the analysis, let's consider only the component of x for the time being and take dou by dou x of r power n. This is equal to n times script r power n minus 1 dou r divided by dou x. Now we want to find out dou r divided by dou x. This is equal to dou by dou x of square root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. This is equal to 1 by 2 times 1 by square root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square times 2x minus x prime. This is equal to x minus x prime divided by script r, and therefore dou by dou x of r power n is equal to n times r n minus 1 x minus x prime divided by r. Similarly, dou by dou y of r power n is equal to n r n minus 1 y minus y prime divided by r, and dou by dou z of r power n is equal to n r n minus 1 times z minus z prime divided by r. When we combine, we have del r power n is equal to x hat n r n minus 1 x minus x prime divided by r plus y hat n r n minus 1 y minus y prime divided by r plus z hat n r n minus 1 z minus z prime divided by r. Therefore, gradient of r power n equal to n r n minus 1 divided by r times vector r. This is equal to n r n minus 1 times magnitude of r times unit vector r divided by r. This is equal to n r n minus 1 times r cap.